So we're looking at day 3, the last main concept, and it's not too bad, right? So we looked at, going back, multiplying and dividing monomials. So one term with one term multiplied, one term with one term being divided. We looked at multiplying on day 2. This time we made it a little bit harder, which you just finished the assignment, multiplying one term with many terms, right? So this is the last new concept, is dividing one term with many terms, right? Not too hard. What we do is we change these questions to make it look like what we did in day 1. So if you're able to do dividing in day 1, this is a half a step extra that you have to do. So what we do is, hey, your numerator is going to have multiple terms. And the terms get separated here. So we're going to create 2 fractions here. There's 2 terms on the top. The bottom is going to have 2, we're going to write this as 2 fractions. So 4x squared is going to be the top of one fraction, and 6x is going to be the top of the other fraction, and the denominator stays the same. Okay? So we take this, our 2 terms, we have a term here, that goes over here, we have a term here, that goes over there. What sign goes between these 2 fractions? Negative. We take the sign from here and put it in between. Okay? So now, we treat it like a question from day 1. We just do one fraction at a time. So we ignore the other fractions. So we do the first fraction ignoring this. So when we divide the numbers, subtract the exponents. So this first fraction simplifies to what term? What do we write down here underneath? Right? So 4 divided by 2 is 2. And the x's, what should the exponent for the x be? Sorry? 3. Not 3. Just x. When we divide, we subtract exponents. So you can give it a little invisible 1 if you can put the 1 in there if you want, but it's not needed. All right? Then we do the next one. We have a subtraction symbol. 6 divided by 2, what do we get? 3. Then x over x, what should we get? Nothing. They cancel each other out. 1 minus 1 is 0, so the x disappears. So the answer is just 2x minus 3. That's where we stop, right? We can't combine those together, right? They're unlike terms. Let's do another one over here. How many fractions am I going to set up? 2. Because on the top we have 2 terms, a term here and a term here. So I'm going to set up 2 fractions. One fraction, oops, like here. One fraction here, one fraction here. The denominator does not change. All right, you take the sign from the middle. That's the sign we put here. Okay. First fraction, 18k squared. Second fraction, 9k. All right. So now we calculate. Going downwards, 18 and 9. What does that give us? 2. 2, because we're dividing them. Excellent. K squared and k. Combine those, what do we get? K. Just a k. 2 minus 1 gives us a 1. Okay. Next one. We have, what do we have? 9k over 9k.
1.
It would be just 1. Minus 1. 9 fits into 9 once, and the k fits into k once. So just 1, right? So you can't make it all disappear. We make it disappear when we have a fraction, but there's also always a coefficient there. It's not nothing, it's a 1, right? If everything gets canceled out, it's a 1. Is that okay? That's a tricky one. 9k over 9k, 1. 9 fits into 9 once. right? That's it, right? All right. So these diagrams here, we're not going to do. All right?
No, not the rectangle.
Not the rectangles. I could teach you how to do it, but I'm not going to bother doing it. All right? And the next 3 questions we'll use as a warm-up next day. So we'll just stop right there. So now the idea is in your head.